Briefing document self-charging electric vehicle SCEV development program date August 5th, 2025, draft pending authorization. Prepared by AI Assistant. 1. Executive Summary. A new era of mobility, the self-charging electric vehicle SCEV development program is a revolutionary initiative aimed at addressing the critical challenge of range anxiety and charging infrastructure limitations in the EV market. The core innovation is to enable electric vehicles to arrive home fully charged through continuous energy harvesting and regeneration during operation, achieving a net positive energy balance during typical daily driving cycles. This ambitious project is backed by a £285 million investment over 36 months, projecting a 340% ROI over 5 years and an 18-month payback period post-commercial launch. Key success metrics include achieving 100% plus energy during 80% of daily driving patterns and capturing 15% market share in the premium EV segment within 24 months of launch. Commercial production is targeted for Q4 2028. 2. Strategic vision and core values. Driving sustainable change. The vision is to empower the future of mobility with self-charging electric vehicles that ensure you always arrive home fully charged, combining cutting-edge technology with sustainable practices to redefine the driving experience. The mission is to engineer self-charging electric vehicles that exceed all safety standards and harness renewable energy efficiently, ensuring each vehicle has the capability to arrive home fully charged. We are dedicated to advancing vehicle safety, energy, autonomy, and driving the future towards a more sustainable world. The company's strategic plan is guided by a prioritized set of core values. Safety 10/10, urgency and importance. Safety is paramount in the automotive industry, ensuring customer well-being and adherence to highest safety standards, aligned with agreeableness. Sustainability 9/10, urgency and importance. Commitment to environmental stewardship, renewable energy sources, and eco-friendly innovation, aligned with conscientiousness, quality 9/10, urgency and importance. Focus on excellence in every aspect of vehicle design and performance. For customer satisfaction and retention, aligned with conscientiousness. Innovation 8/10, urgency and importance. Drives progress and market leadership by exploring new ideas and continuous improvement. Aligned with openness. Customer centricity 8/10, urgency and importance. Places the customer at the forefront of the company's priorities. Aligned with agreeableness, leadership 7/10, urgency and importance. Striving to set industry standards and inspire others. Aligned with extroversion, integrity 7/10, urgency and importance. Building trust with stakeholders through honesty, transparency and responsibility. Aligned with conscientiousness, adaptability 6/10, urgency and importance. Remaining agile and responsive to changes. Aligned with openness, collaboration 6/10, urgency and importance. Working effectively with partners, suppliers, and within the team. Aligned with extroversion, respect 5/10, urgency and importance. Valuing diversity, fostering a culture of respect, and ensuring inclusivity. Aligned with agreeableness. 3. Key technological breakthroughs and energy harvesting methods. The SCEV's innovation lies in its integrated multi-source energy harvesting system. Key technologies include advanced solar photovoltaic systems, featuring a roof-mounted flexible solar array with 4 OOW plus generation capacity, alongside hood and trunk solar integration with seamless aesthetic design. The target efficiency is 99.2%. Kinetic energy recovery systems includes regenerative braking, optimization with 95% energy recovery efficiency, and wheel hub kinetic energy generators with magnetic levitation technology. Thermoelectric generators, TEGs, utilizing waste heat from drivetrain systems to generate electricity. AI-powered energy optimization system employs machine learning for predictive charging algorithms, real-time energy balance, monitoring, weather-adaptive charging strategies, and route optimization for maximum energy generation during travel. Advanced battery architecture Incorporates solid-state battery cells with integrated thermal management. Aiming for 500,000 plus mile battery life with 10% degradation. Vehicle 2-grid V2G capability. Allows bidirectional energy flow for home energy supply. Further, energy harvesting methods under investigation include wheel rotation to generate energy via electromagnetic induction. Estimated output 1 to 5 kilowatts. Suspension energy harvesting. Utilizing vehicle suspension movement. Flywheel energy storage. Storing and releasing energy 10 to 50 kilowatts energy release. Piezoelectric energy harvesting. Generating small amounts of power from vibrations 0.001 to 0.1 kilowatts. Wind turbines. Experimental small turbines mounted on vehicles. The objective is to optimize the power output of mechanical generators at low rotational speeds and convert small currents into high voltage and electrical output. 4. Market context and competitive advantage. The global EV market is projected to reach $1.7 trillion by 2030, with self-charging capability identified as the next evolutionary step, potentially exceeding $450 billion by 2035. The SCEV aims for first-to-market advantage by eliminating range anxiety and charging infrastructure limitations. Competitive landscape highlights. Tesla Model S strengthens supercharger network and brand, but limited self-charging capability. Our advantage. Integrated multi-source energy harvesting. Mercedes EQS. Luxury positioning with a solar roof option, but minimal energy generation capacity. Our advantage. 300% higher energy generation potential. BMW iCAS. Strong in technology, integration, and efficiency, but no self-charging features. Our advantage. Complete energy autonomy system. Lucid Air. Range leadership and luxury, but traditional charging dependency. Our advantage. Elimination of charging infrastructure needs. Lightyear Zero. Solar integration. Pioneer, but limited production. High cost. Our advantage. Mass production capability with cost optimization. The SCEV targets an unlimited daily range through self-charging compared to the industry standard of 350 to 500 miles, with continuous charging during operation versus the typical 30 to 60 minutes. The target premium of price range is £95,000 1 to 5K with a self-charging premium. 5. Project scope and deliverables. In-scope deliverables. Core vehicle development. Complete SCEV platform design with integrated energy harvesting systems, aerodynamic body, and intelligent battery management. Energy harvesting technologies. Flexible solar arrays for OOS+, wheel hub kinetic energy generators. Advanced regenerative braking, 95% efficiency, and thermoelectric generators. Smart energy management. AI-powered optimization, real-time monitoring, weather-adaptive charging, route optimization, and V2G capability. Manufacturing and production. Production line set up for 50,000 units annually, scalable to 150,000, 99.8% defect-free production, and supply chain management for specialized components. Technology. Integration. ADAS optimized for energy efficiency. Connectivity platforms. And over-the-air OTA updates, regulatory and certification, NHT, SA, EPA, international safety compliance, and patent portfolio development for proprietary energy harvesting technologies. Out-of-scope exclusions. New manufacturing facility, construction existing facilities to be modified, traditional plug-in charging infrastructure development, and advanced features beyond Level 2 ADAS for future phases. 6. Project timeline and investment. The project follows a 36-month development cycle, with commercial production launching in Q4 2028. Milestone target, date, budget allocation key, deliverables M1, concept. 28, 202, 6.25, Monarchy Harvesting Feasibility Study. Initial prototypes M2. System Designog 31. 2,026 pounds for 5 complete vehicle architecture. Energy system integration, design 3. Prototype development Feb 28, 202,765 functional prototype vehicles. Energy system validation 4. Production preparation AUG 31, 202,755 manufacturing line setup. Supplier qualification, regulatory approval SM 5. Market launch preparation Feb 28, 2028, pound 45. Mofino validation, dealer training, marketing campaign. Initial production 6. Commercial production AUG 31, 2028, pound 50 full-scale production. Market launch. Customer delivery total approved budget, 285 million pounds. 7. Governance and leadership. The project adheres to an enterprise project management framework, PMBOK 7th edition compliant approach, validated by PMO co-review. The executive sponsor is the Chief Technology Officer, CTO. Key stakeholders. Executive leadership. CTO, executive sponsor. CFO, VP engineering, VP marketing steering committee, board of directors, project team. Project manager to be assigned. Chief engineer, energy systems lead, manufacturing director, technical team. Vehicle design led, software engineering led, battery technology led, testing and validation led. Business stakeholders. Product marketing director, sales director, regulatory affairs manager, supply chain director. External stakeholders. Regulatory agencies, NHTSA, EPA, technology partners, customers, investors, leadership team, personality traits, Big 5 alignment. The strategic alignment of core values with the Big 5 personality traits informs ideal leadership profiles. CEO. High in openness, conscientiousness, agreeableness, extroversion, and emotional stability. CFO. Primarily conscientiousness, with a balance of openness and strong in conscientiousness, openness, and emotional stability. CMO, high in openness and extroversion, balanced by CTO, executive sponsor, leads with openness, conscientiousness, and extroversion, also valuing user experience, sustainability, and adaptability. Chairman, vice chairman, lead director, similar to CEO, valuing openness, conscientiousness, extroversion, agreeableness, and emotional stability for strategic direction and oversight. 8. Risk management and quality assurance. A comprehensive risk management framework is in place, categorizing risks into technical, regulatory, market, and supply chain. A risk register details specific risks, for example, solar cell degradation, regulatory approval delays, and their mitigation strategies. For example, R001 solar cell efficiency degrades faster than expected, is mitigated by extensive testing, warranty partnerships, backup technologies. Quality management is paramount, adhering to ISO TSO TS 16949 Automotive Quality Management System compliance, targeting NHTSA 5-star safety rating and complying with ISO 14001 environmental management. Rigorous testing strategies include component integration, durability, environmental, and safety testing. Coupled with continuous improvement frameworks throughout the development lifecycle, the target defect rate is less than 0.2% defects per vehicle in energy systems.